everyone. Today we're going to start our first virtual lesson. Where we left off in class was talking about section 9.8 in the textbook, which is using measurement in the workplace or measurement applications. So what I decided to do is we're going to go back from the beginning of this section, which you should have in your notes, and I'm going to go through all of the questions again and continue on until the end for this video. Feel free to pause us as we go through if there's something that you're not understanding. And then during our class times, we're going to be meeting via Skype if you have any questions. So let's get started. So for number 1 in this section, it says, a doctor's office needs to order carpet for the waiting room. The room measures 30 feet by 25 feet. How many square feet of carpet are needed for the room? And then for the second question, the carpet's sold in square yards, so how many square yards are needed? They also tell you that area equals length times width, which is something that we're going to have to do for this question. So now when I go through and look at what the question is asking, it's asking for how many square feet are needed. The measurement square is an indication that area is being asked for here. So we need to find the area of this room in feet. So area equals length times width. So what we're going to do is find the area, making the 30 feet the length, and then the 25 feet would be the width. Then I'm going to multiply those together. So 30 times 25 is 750. And feet times feet is feet squared, which we say 750 square feet. So we just answered the first question. It's 750 square feet for the carpet. Now, for the second part, it says the carpet is sold in square yards. So how many square yards are needed? So since we have square feet and we're being asked for square yards, we can just do a conversion. Basically what the question wants to know is this. How many square yards is 750 square feet? So we're going to go to the type of measurements we've got. Feet, even though it's squared, feet is a U.S. measurement, and yards is a U.S. measurement. When I go to set this up then, that means I need to set it up with unit fractions. So I'm going to take the 750 square feet that I start with, and put that over 1, and then I'm going to use a conversion for this next one, putting the square feet diagonally across so that those cancel. Square yards is what I want, so that goes in the top. And then I'm going to fill in the numbers using the conversion sheet that I have. Okay, so we're talking about a U.S. system to a U.S. system measurement of area. So I'm looking on this side of the page for square yards and square feet. And I see that one right there. 1 square yard is the same as 9 square feet. So I'm going to fill the numbers in on my paper. And then I'm going to take this straight across. So 750 times 1 is 750, and 1 times 9 is 9. The square feet are diagonal, so they cancel, and square yards are left. Now, since I'm looking at a fraction right now, I know I need to divide that. 750 divided by 9 gave me 83.3 repeating. So if I round it to the 10th, it's about 83.3 cubic yard, or square yards. But if I'm going to buy this, I'm going to round it and make it 84. That way I know I have enough. Okay, number 1 is done. Let's move on. Okay, so number 2 says, fitness experts tell us that we should walk 10,000 steps each day to stay healthy. The person's average step length is 34 inches. How many inches would they walk in 10,000 steps? And then how many feet is that? How many miles? And round to the tenths. So for this, let me first jot down what we're given here. We're walking 10,000 steps, but it tells us that a person's average step length is 34 inches. What that means is we have a conversion we can use. 1 step equals 34 inches is a conversion that is similar to the ones on the paper. So we're going to use that when we're working with this. They want to know how many inches in 10,000 steps. So this steps is our starting unit, and we're going to convert it to inches using unit fractions. So I'm going to take my starting unit and put that over 1. And then steps needs to be diagonal so that that cancels. Everything I'm looking for, which is inches, goes at the top. That should be the only thing left. Then I'm going to place these numbers in as if they were a conversion from this page. So 1 step is 34 inches. So it sets up like that. Next, I'm going to go straight across. So 10,000 times 34. Over 1 times 1. The steps cancel, and inches are all that's left. And now since you're looking at this, over 1 just means you're done. So 10,000 steps would be 340,000 inches. Okay, so now that I have inches, I can convert that to feet. So I'm going to use that as my starting point. And put it over 1. And then make sure that inches are diagonal so that they cancel, and feet is what we want. Inches is a US measurement, feet is a US measurement. So I'm going to go with the unit fractions again. And then I know that there are 12 inches in a foot, which if you forgot, it's on here. And then go straight across. 340,000 times 1. Over 1 times 12. Inches cancel, and feet is left. Now I'm looking at a fraction, and now I know I need to divide. Okay, so 340,000 divided by 12 gave me 28,333, and 3 repeating. So to the tenths, it would be 0.3 feet. Now that we have feet, we can change to miles. So again, for this, we're going to take this amount and make that our starting point. We're going to put it over 1. Put feet diagonally across, and miles go in the top. Feet and miles are both US measurements, so I'm going to be going to my conversion page again and looking for miles to feet. So it's US to US, so I'm over here on this side, and I see that 1 mile equals 5,280 feet. I'm going to fill that in. And then I can go straight across one more time. One times 5,000 280. The feet are going to cancel, and miles is all that's left. And again, it's a fraction, so we need to divide. I got about 5.36, so 2 nearest 10th. That's about 5.4. And there's your miles. So that one's done. Alright, number 3 says criminal possession charges are based on the weight of the drug the suspect possesses. If the suspect possesses between 2 to 4 ounces of illegal drug, the charge will be a Class A2 felony. The suspect possesses 100 grams of cocaine. How many ounces does the suspect possess, and will he be charged with this Class A2 felony? So, some information that we've given. The suspect can't possess between 2 to 4 ounces, otherwise he'll be charged. And he's got 100 grams. The question wants to know how many ounces does he possess. So we're going to start by trying to convert the grams that he has to the ounces that they're asking for. That way we can see if it's in the range. So grams is a metric measurement, but the ounce is US. So what I'm going to need to do is unit fractions for this. And this time, before I even get started, I'm going to look and see if I can do it. So on the right side of the paper, these are the metric to the US measurements. So I'm looking for grams and ounces, which is the measurement of weight. And on the bottom here, I see that 1 ounce is the same as 28 grams. So I can do this conversion using unit fractions. And that's the information that I need right there. So I'm going to start by putting the 100 grams over 1. And put the grams diagonally across so that they cancel. The ounces that you want go in the top. And it says 1 ounce is 28 grams. So I fill my numbers in. And then I multiply straight across. 100 times 1 is 100. 1 times 28 is 28. The grams would cancel. An ounce is the new unit. Now, since this is fraction form, we're going to divide. I got about 3.5714, so let's make that 3.6. Okay, if he possesses 3.6 ounces of cocaine, that is in between the range here for the charge that they're asking for. So yes. He's going to be charged. Okay, that one's done. Let's move on. Okay, number 4 says, Mary is 5 feet tall and Alice is 1.6 meters tall. Who is taller and by how many inches? So, with this question, since they're asking for how many inches taller the other one is, we might as well just change them both to inches, and then we'll be able to subtract and see who's taller. If they didn't ask for how many inches, you could change them to anything as long as they were the same. You could make them both feet, you could make them both meters, you could change them both to inches anyway, but as long as they match, you'd be able to compare them. So, let's start with Mary. She's 5 feet, and we're going to change that to inches. So, feet is US, inches is also US. So we're going to do unit fractions for this. Putting the 5 feet over 1. Feet will go diagonally across, so it cancels, and inches go in the top. There's 12 inches in 1 foot, and then take it straight across. 5 times 12 is 60. 1 times 1 is 1. The feet cancel, and inches is the unit. Since it's 60 over 1, that's just 60. So Mary is 60 inches tall. Now let's look at Alice. Alice is 1.6 meters tall. We need to change that to inches. Meters is metric. Inches is US. So before I get this started, I want to check and see if I can do it, because when I'm going from one system to the next, sometimes I have to do a little bit of extra work. So when I look on the right-hand side with metric to US measurement conversions are, I'm looking for length, and I don't see meters and inches. The closest one that I see is the inch to the centimeter. So when you're working with questions like this, you need to go with the one that is the closest. So you're being asked for inches, so you have that one here, but that one will take you to centimeters. So question needs to be rethought now. Let's see if we can do it this way. If I'm starting with 1.6 meters, if I could get it to centimeters, then I could get it to inches. So if I have a meter, I'm going to go to centimeter, which then could take me to the inches that I'm looking for. That's my thought process. So now let's try this again. The meter is metric. The centimeter is also metric. And the inches is US. So when I go to do this first step here, when I see that they're both metric, I know that I can use the metric prefix line down here. King Henry died by drinking chocolate milk. So that's what I'm going to do. The base unit in this case is the meter, which is where you start. We're trying to go to the centimeter, which is 2 places to the right. So I'm going to move my decimal 2 places to the right. And it's now here, which means I need to fill this in with a 0. So 1.6 meters is the same as 160 centimeters. Okay, so now that I have the centimeters, now I can get to inches. And we're going from metric to US now, so I'm going to go back to the unit fraction setup. So I'm going to take the 160 centimeters that I'm working with now and put that over 1. Centimeters will go diagonally across, so it cancels, and the inches that I'm looking for will go in the top. And again, I'm going to pull this into it. I'm using 1 inch equals 2.54 centimeters. And then I can multiply this straight across. 160 times 1 is 160. 1 times 2.54 is 2.54. The centimeters cancel. Inches is the new unit. And I'm looking at a fraction, which I'm going to divide. I got about 62.99. So I'm going to round that off and make it 63. And there's Alice. So Mary was 60 inches, Alice is 63 inches, which means that Alice is taller by 3 inches. Okay, that one's done. Okay, number 5 says a doctor prescribes a dose of 3.5 cc's of codeine elixir for a patient. How many milliliters of the drug will the nurse administer? So this one is something we haven't talked about yet. It's telling us we start with 3.5 cc's. cc's is cubic centimeters. But technically, it's a metric measurement because it's equivalent to 1 ml. So 1 cc is the same thing as 1 ml, which, by the way, measures 1 gram. But the point is, if you have cc's, you have mLs. They're the same thing. So if they want to know how many milliliters they're going to administer, there's nothing to solve here. If it's 3.5 cc's, it's 3.5 mLs. That's it. Okay, number 6 says a vehicle is traveling at a rate of 80 kilometers per hour. How many miles per hour is this? So they're asking you to convert 80 kilometers per hour to miles per hour. Because your time already matches, there's nothing to do there. Those are the same. But your lengths don't match. You're going from the kilometer, which is metric, to the mile, which is US. So we need to convert 80 kilometers to miles. Since we're going to do that, we're going to check this little conversion sheet, see if we can do it. We're looking for one system to the next, which is the right-hand side. And I see that 1 mile is 1.6 kilometers right there. So we can do it, but we're going to need to do unit fractions for this as well. So we're going to take the 80 kilometers and put it over what? Kilometers will go diagonally across in the bottom and miles in the top. There's 1 mile to 1.6 kilometers. Then I'm going to multiply straight across. 80 times 1 is 80. 1 times 1.6 is 1.6. Kilometers cancel. The miles is the new unit now. And now I'm looking at a fraction, so I need to divide. I got 50. So 80 kilometers per hour is the same thing as 50 miles per hour. Okay, that one's done. Let's move on. Okay, so on to number 7, which says a vial of medicine contains 60 fluid ounces of medicine. If one dose consists of 75 milliliters, how many doses does the vial contain? So in this question, they're giving you the total amount of fluid that you have in the entire thing, and then they're telling you how much one little piece of it is. If they're asking for how many pieces you could make out of that, then you need to divide. The problem is we have fluid ounces and we have milliliters. So we need to pick one of them to convert to, and then we'll be able to divide. I'm going to choose to take the 60 fluid ounces over to milliliters. But you could do it the other way. So I'm going to change this to the milliliters, which will then match with the 75. So fluid ounces is US. Milliliters is metric. So I need to look and see on the right-hand side of my paper if I can even do this. We're talking about liquid here, so I'm looking under the volume section of this conversion sheet, and I see that 1 fluid ounce is 30 milliliters. So I can do it, and that's the information that I'm going to need to do it. So I'm going to take my 60 and put it over 1. And then the fluid ounces will go diagonally across, so that cancels. And milliliters is what I want, so that goes in the top. it says 1 fluid ounce is the same thing as 30 milliliters. So I'm going to fill it in that way, and then I'm going to go straight. So 60 times 30 is 1800. 1 times 1 is 1. The fluid ounces cancel, and the new unit is now milliliters. Since this is just over 1, that's your answer. We're not done. What we did was we figured out how much liquid we have total now in the entire vial. We have 1800 milliliters. So now we can divide. So we're going to take the 1800 from the amount from the entire vial and divide it by the 75. Which gave me 24. So we'll be able to get 24 doses out of that vial. Okay, let's move on. Okay, number 8 says Mexican currency is the peso. 1 Mexican peso is currently equal to 0.055 US dollars. If a traveler exchanges $400 for Mexican pesos, how many pesos will he receive? And we're going to round it to the nearest whole number, the nearest peso. So in a case like this, they're giving us conversions to use, just like a previous question, as if they were on this conversion sheet. So we're going to set this up with unit fractions, and we are going to use the fact that 1 Mexican peso is about 0.055 US dollars. So that's the conversion that we're going to use. The traveler is exchanging $400 and wants to know how many pesos that will be. So we're going to put the $400 over 1. And then the dollars are going to be diagonal so that they cancel. And the thing that we want, which is the pesos, will be in the top. Then we're going to fill this in using this as our conversion. So 1 peso is that many US dollars. So it sets up like this, and then we're going to go straight across. So 400 times 1 is 400, and 1 times 0.055 looks like that. The dollar signs canceled. The peso is the new unit. And we're looking at fraction form again, so we need to divide. So I got that, 7,272.7. So to the nearest peso, that would become 72.73. Okay, let's move on. For number 9, it says a child weighs 53,690 grams. How many kilograms does the child weigh? So they're asking us to convert 53,690 grams to kilograms. Grams is metric. Kilograms is also metric. So we can use the metric prefix line. Okay, so the base unit in this case is the gram, and that's where you're starting. And we need to convert it to kilograms, so we need to move it 3 to the left. So starting at the end, since this is a whole number, decimals at the end, we need to move it back 3. 1, 2, 3. Puts it between the 3 and the 6. And we talked about this in class. When you have a 0 after to the right of your decimal, you drop it off. And so our final answer is going to be 53.69 kilograms. In number 10, a medicine bottle contains 8 grams of medicine. One dose is 400 milligrams. Part A, they want to know how many milligrams does the bottle contain. So the bottle is 8 grams, and they're asking for milligrams. Grams is metric. Milligrams is also metric. So just like in the previous problem, we can use the metric prefix line. Your base unit is the gram, and that's where we start. And we're moving 2 milligrams, which is 3 to the right. 8 is a whole number, so again, just like in the last problem, you're starting at the end of it, and then you're moving it 3 to the right. So fill those in with zeros, and there are 8,000 milligrams in 8 grams then. Okay, for part B, it wants to know how many doses does the bottle contain. So we did a previous question that was just like this before also. You're given your total, which we now have in milligrams, and you're given the amount in one dose, which is also in milligrams. So we can divide these two to see how many doses we can make out of this. So it's going to be 8,000 for the total, divided by 400 milligrams in one dose, which is 20. So we can get 20 doses out of that. All right, number 11 wants you to arrange the measurements from the smallest to largest. And the key to this is making sure that all of the units match. So you have liters, you have deciliters, and you have milliliters. It doesn't matter which one of these you pick, but you've got to pick one and change the others to that. And then you'll be able to decide. You need to compare these like apples to apples. Okay, so how do we decide which one we're going to pick? Well, for me, I'm looking at these and I see liter, deciliter, milliliter are all metric, which means that I can use the metric prefix line to convert these. And since liter is the base unit, I'm going to choose to change them all to that. We already have one in liter, so I'm going to change deciliter, the 45 deciliters that we have here, to liters, and I'm going to change the 450 milliliters also to liters, and then everything will be in liters. We'll be able to compare it to the 2.1 liters that we're going to leave alone. Okay, so first let's start with the 45 deciliters. Deci is this one here. So you're starting here, and we're going to move it to liter, which means we need to move it back just one time. So your decimal is behind, move it back one time, and now it's 4.5. Then for the milliliter, you're starting over here, and we're going to move it back 1, 2, 3 to get it to liter. So starting at the back. 1, 2, 3, puts it in front of the 4. I'm going to drop the 0 off because it's now to the right of the decimal. So here are my 3 measurements, all in the same unit, and now I can compare them. So from smallest to largest, this one is the smallest, then 2.1 is smaller than 4.5, and this one is the largest. When you put them in order, we usually go back to the original way that they were given. So 450 was first, then the 2.1 liters, and then the 45 deciliters was the largest. All right, for number 12, it says iron melts at around 1,510 degrees Celsius. What is its temperature in Fahrenheit? So this is a question that requires a formula. So on the bottom of your sheet, you have the formulas for temperature. Since we're asked to change it to Fahrenheit, you want Celsius to Fahrenheit. You have these two choices. They both give you the same answer, and I'm going to use the one that is decimal form. So what I'm going to do is write it down first. And then I substitute in place of C. I'm going to remove this and put the Celsius that I'm given from the problem in place of it. Anytime you have a number right next to a variable, that means multiplication. So we're multiplying 1.8 times 1510 plus 32. And you're going to follow the order of operations when you do this. If you just plug this into your calculator this way, then the calculator will do the order of operations for you. So after I plugged it in, I'm getting 2750. That sounds super high, but it is. You're melting metal here, so that's why it's so high. Okay, that one's done. Okay, 13 says, to ship a package, a freight carrier charges 75 cents for the first pound and 25 cents for every pound or part of a pound over that. The package weighs 3,456 grams. How many pounds does it weigh, and how much will it cost to ship? So first, we need to change our weight to the pounds that they're asking for. We're starting with 3,456 grams, and they want it changed to pounds. So grams is metric, pounds is US. Which means before I even start, I'm looking over here on the right, and I'm going to try to find something that will convert this. I don't see anything that will go from grams to pounds. I see ounces and grams, I see pounds and kilograms, and I have two choices for that. So what I'm going to try to do is just pick something that's closest, and then I'll be able to work from there. So what I'm going to choose to do is go with the 1 pound equals the 0.45 kilograms. There, like I said, you can do this in a number of ways, but this is the one I'm going to choose to do it. So what I'm going to end up doing is I have to recreate this problem a little bit and back up. I'm going to go from grams to kilograms, and then once I have kilograms, then I'll be able to get to pounds. So that's my thought process, and that's my plan. So now let's reevaluate. We started with grams, which is metric, and we're going to go to kilograms, which is also metric. And then from there, then we'll go to pounds. which is US. So again, when I do this first step now, since I'm going from metric to metric, I can use the metric prefix line. My base unit is the gram, and I want to change it to kilogram. So I'm starting here, and I need to move back 1, 2, 3 places to the left. So I'm starting in the back of the 6, and I'm going to go 1, 2, 3 to the left. That puts it between the 3 and the 4, and now it's 3.456. Now that I have that, now I can get to pounds. But now, since I'm going from metric to US, I'm going to use the unit fractions again. So I've transformed my problem. I'm now looking at kilograms. So I'm starting with that. And I'm going to put that over 1. Kilograms diagonally across so that they cancel. And now I can get to pounds. So again, since I'm choosing the 1 pound equals the 0.45 kilograms, I need to make sure I place these correctly. Next, I'm going to take it straight across. So 3.456 times 1 over 1 times 0.45. The kilograms cancel. The pounds is the new unit. And since I'm looking at this fraction, I know I need to divide. So once I did that, I got 7.68. There's the first answer. Now going back up here, it wants to know how much is it going to cost to ship this. So let's go back and look at this information. It's 75 cents for the first pound. We have much more than 1 pound. So if we remove the first pound from this, which is going to cost us 75 cents, so the first pound is 75 cents. That pound is being accounted for right here. What's left is 6.68 pounds that we haven't paid for yet. Now, it costs 25 cents for every pound and part of a pound. So we have 6 full pounds plus part of a pound left over right here. So we have 7 things that we need to pay for. These right here are going to cost 25 cents each. And this partial pound that we have, the 0.68, is also going to cost 25 cents. So 6 pounds at 25 cents plus the partial pound at 25 cents means we're going to need to multiply 25 cents times 7 and add it to our first pound. Okay, after I plugged that in, I got 2.5, which means it's going to cost $2.50 to ship the package. Okay, there's 2 answers. That one's all done. Okay, for the last one here, it says, many insurance companies base their rates on a person's BMI, which is body mass index. BMI rating is an indicator of a person's health. So the BMI is calculated by taking the person's weight in kilograms and dividing by the square of his or her height in meters. This is the formula for it right here. So weight in kilograms over a height in meters, and then you square that. And then John weighs 185 pounds and he's 6 feet tall. So what's his BMI? After that, we're going to talk about whether or not he is healthy. So based on his BMI, we'll be able to put him into one of these categories. In order to do that, we first need to get his weight in kilograms. So he weighs 185 pounds. And we're going to change it to kilograms. Since pounds is US and kilograms is metric, I'm going to check over here on the right side of my conversion page and look and see if we have a conversion for this. This is the one that there's two different ones you can choose from. You can pick 1 pound equals 0.45 kilograms, or you can pick the 1 kilogram equals 2.2 pounds. Just to make it easy, I'm just going to stick with 1, and I'm going to pick the first one. So we're going to use unit fractions for this. We're going to put this over 1. The pounds are going to go down on the bottom immediately so that those are diagonal, and they'll cancel. The kilograms will go in the top. If I'm using the first one, then the 1 goes with the pound, and the 0.45 kilograms goes in the top. Then I'm going to take it straight across. So I'm going to multiply 185 times 0.45, which is 83.25. One times 1 is just 1. Pounds cancel, and the new unit is now kilograms. Since this is just over 1, it's our answer. There's his weight. Now, we need to find the height in meters. He's 6 feet tall. So we're going to convert that next. So since we're talking about US to metric again, I'm going to look over here on the right, and this time I need to find something in the length section. So feet and meters. I see feet to centimeters, and I see meters to yards, but I don't see feet to meters. So I need to find something that's close. I'm going to pick the feet to centimeters one. The other one would have worked too. I'm just going to pick the first one that I see though. So what I have to do now is I have to do a two-step process. I'm changing the 6 feet now to the centimeters that I saw here. And then from centimeters, I'm going to go to meters. So 6 feet is US. We're going to change that to centimeters, which is metric. And then from centimeters, we'll be able to get to meters because that's also metric, which means we'll just be able to move the decimal. So let's start with this. This is US to metric, so that's a unit fraction setup. Feet are going to go diagonally across. Centimeter is on the top. It says 1 foot equals 30 centimeters. So 1 goes with the foot and 30 goes with the centimeters. Now I'm going to take it straight across. So 6 times 30 is 180, and 1 times 1 is just 1. The feet cancel, and centimeters is your new unit. Since this is just over 1, we can drop that, and we have 180 centimeters. So now we can get to the meters that we need. Metric to metric is the metric prefix line. The base unit in this case is going to be the meter. But we're starting on the centimeter. So we're starting here, and we need to move it back to the meter. So we're going to go back 2 places to the left. Starting back of 180, we go 2 places to the left. That puts it between the 1 and the 8. And you can drop the 0 at the end because it's to the right of the decimal. So now you have the weight in kilograms and we have the height in meters. So we can now take these two things and plug them into that formula and find the BMI. The weight in kilograms is 83.25. Divided by the height in meters has to be squared. So we have the height in meters is 1.8. We need to square that. When I plug this into my calculator, I plugged it in as 83.25 divided by 1.8, and now I'm going to square it using my square key. On all of the scientific calculators that you guys have, you have a button that says x squared. You can just press that and then press enter, and it will calculate it all for you all at once. I'm getting 25.694 repeating. So let's round that off and make it 25.7. All right, so here's our BMI. Here's our answer. If we need to figure out if he is healthy now, we have to figure out where this lies in the range. 25.7 is between 25 and 29.9. So John, with a 25.7 BMI, falls into this category. Not by much, but it falls into this range. So he would be considered overweight by the insurance company. Okay, that's the last one. So this video is finished. To move forward, what I would like you guys to do is now take a look at all of your homework, ask me any questions about this when I set up the Skype meeting, and we're going to go from there. Moving forward, I'm going to create videos like this for each of the lessons, and we'll do them all virtually, and you'll have a chance to interact with me in real time via Skype during our class time.